I welcome you all to the Spark Research YouTube channel. This is Dr. Vichandra, Assistant Professor in the Department of ECE, and this is the another session of this course, Signal Processing. And we are going to take some questions, particularly from this unit first and second, as an exercise. And these questions has already asked in the previous year CT, right? So we will take the questions. Also, apart from this, you will get the updates related to the previous year questions in the semester exam that has asked, and also the previous year gate solutions. We will look into them. Okay, so first of all, total there will be the 4 questions, and out of that, you have to solve the 3 questions. And so let's talk the first question, right? So here, the very first question, 1A is your which of the following statement is correct? So statement 1 is your del n is the integral of un. That is not correct. This del n is the differentiation of un, right? So second one is correct. Un is the derivative of rn. Rn is your ramp function. So un is the derivative of rn, and rn is the integration of un, right? And integration of del n is your un, right? So Rn is the always negative. So this is not, it's a positive, and Un is always. So actually you should remember concept is the differentiation of your RT, that is ramp function, is step, and differentiation is step is del. And similarly integration of del is U, that is a step, and integration of step is ramp. Second question, discrete time causal. Action is said to be causal. So causal means it should not depend on the future, right? So action, so here n should not be 0, less than equal to 0. Otherwise it will depends on the future, right? So this is correct. Remaining all are not correct. The absolute integrity condition state that this must be finite, right? In order to satisfy the energy signal, right? And lastly, the Fourier transform of impulse function is always 1, right? Okay. So next question, design a discrete time signal action using the 7 digit, and which are the, and while the following constants below. So some constants is given, assign these values to action over the range n is equal to -3 to n is equal to 3, ensuring a mix of positive and negative values of your register numbers, right? So you can choose and write down the sequence and then plot it. So you can choose any number. So here the suppose action is there, so the amplitude are there, and for the 7 different values of the n, right? So n is varying from -3, -2, and 2, and till +3, right? And correspondingly you can choose any values of the amplitudes, despite it should have the some positive and the some negative, right? And thereafter you have to do x of n minus 3. So shift right side in the the that is by 3 amount, and minus n take the reversal, that is time reversal, and then plus 2, that is shift in the leftward direction. So twice of n, x of twice of n. So you have to the multiply in the time domain, so it will compress your graph, and this will again expand your graph. So similarly you can do these plots. Okay, next question, prove the frequency shift property by applying the frequency shift to the analysis equation. X of j omega is given. Prove that the frequency shift property by utilizing the Fourier transform of exponential of j omega t in conjunction with the multiplication property. So we have already proved it in our previous session. I will drop the link in the description section. You can check it. So this is very simple. So what to do in the frequency shifting property, just you have to multiply by the the e to the power j omega t. So here suppose this is your fx xt is the original signal, and this is the shifting, so e to the power j omega t. So you can the solve it using the basic Fourier transform properties, that is the integration over minus infinity to infinity, and xt this term, and this is the minus j omega t because of the Fourier transform. Now if you will solve, you will get the omega minus omega naught. So this is the shifting in the frequency if we are multiplying with the e to the power j omega t, right? And multiplication property you can do like x1 and x2, you can they use this property, and where denotes the convolution. X1 and x2 both are convolution. So the from the Fourier transform, this one will be the we know the Fourier transform of e to the power j omega t twice by del omega minus omega naught. So we'll use this property and we'll get the same value, right? So yeah. And another one here, the in the further system yt is equal to tx to the power t. So is this we have to check linearity, dynamic, and the causality, all these things. So the it's here, from here only it shows that exponential function present in the system equation makes it non-linear, right? So t is there. If t we can remove na, then this will be linear, right? And then dynamic, since depends on the present time, so this system does not require memory unit. So if it is not required memory, means dynamic, not static. Okay. Third one, does satisfy the superposition principle? No, right? Because additive property will not satisfy. Also this is non-linear, right? And non-linear always will not satisfy the superposition principle, always, right? So if it is non-linear, no need to check whether will it follow the superposition or not. Then causality, since it doesn't, it depends on the the future, so definitely this will be the causal, right? So it will not this is the non-causal. Okay, so what is the total energy of the discrete time signal x n, which takes the value of unity at n is equal to these values, right? So here you can add all these like the summations, and since these at minus 1, 0 and 1, it have the values 1, 1, 1, so you will then you can get the final value of 1, 1, 1, that is 3. Now classify whether the signal this is energy or power. So just integrate it, x square like fx x square and with respect to dt, and if it is finite energy means energy signal, and if it is finite power means finite power. So of course here this is the it have the finite energy, so this is the power signals, okay, finite power, okay. And so here now another question is that sketch the even and odd parts of the signal here. So how will you sketch the even and odd parts? So odd, you can write the technique is that half of fx plus f minus of x. So here half of xt plus x of minus t. If you will do this, then you will get the even part. Similarly, half of xt minus of x of minus t. So in that manner, you will get the odd part. So first fx is there, ft is there, f of minus t, that is time reversion, and this is the even part, that is the half of xt plus x of minus t. Similarly, this is the odd part, that is half of xt and minus of x minus t, right? So you can get all these values. Another question is that obtain the Fourier transform of a sinusoidal signal, right? So you can first convert into the exponential function using the Euler's theorem, that is sine theta. You can write like this, and then individually you can transform into the Fourier transform, right? Finally, you will get this value. That's all in this session. Thank you to join. Okay, one more question is there, right? So here determine the inverse Fourier transform. So how will you determine the inverse Fourier transform? So the 1 by twice pi and minus infinity to infinity, and there is fx is already given. So you can put all these for the different domains and you will get the final value. Okay, consider the signal this and using the differentiation integration property Fourier transform, where this is given, you have to get the value of xt, right? So xt you can write down the values, and then whenever you are integrating, the integration term is there, you can use this 1 over the j omega, and for differentiation s of j omega, right? So you can use this property and you can get the values. Okay, that's all. Thank you to join the sessions. If you have any doubts, drop your comments.